Hey guys, welcome to our first lecture. I always like to start off this class by telling you why you care about it, other than the fact that you have to have it to graduate. And I like to bring this up because statistics is kind of a daunting topic and not everybody gets it. So, point being, usually when we have in-person classes, I take a poll to see how many of you are actually interested in conducting research, going into teaching, whether it be high school or college. If you're going into corporate wellness, fitness, personal training, physical therapy, occupational therapy, you want to be a physician's assistant, whatever, right? And I mean, even for those of you who don't know what you want to do yet, which is totally fine, right? Everybody will benefit. Doesn't matter where you're going within the realm of kinesiology, but this class should benefit everybody, right? Because if you, let's say, are a strength and conditioning coach, right? How do you know that your approach is appropriate to use on certain individuals, right? Usually we have practices that are informed by research. So being able to read research, kind of pull apart study designs, understanding the results, and then seeing or evaluating if the investigators interpreted those results and created appropriate conclusions. That's important for you to know for your jobs, right? So that's why this class is important for everybody. So whether you're here just to meet a requirement or not, you will get something out of this. At best, you'll be proficient in Excel and you can put that on your resume when you move on into the world. So this first part of the Module 1 lecture is going to be on types of measurement and data. Really the first couple, like this first module, in addition to, let's say, the next module, actually no, the first 3 modules, these are all fundamental concepts of statistics that will keep recurring throughout the course. So if you don't get stuff this week, like, you'll still get practice in the coming weeks. Types of measurement and data is a thing that I will ask you guys all the time. So I give you a research scenario and I'll say identify some variables and then identify the types of measurements or the type of data these variables represent. When we collect measurements, we have to look at who we're actually collecting. So in statistics, we have to make a very clear distinction between the population and a sample. So a population is going to represent a group of persons, places, or objects that have at least one common characteristic. So we could say, I want all of the students from Cal State Long Beach. That would be considered a population. Okay. Maybe I want to consolidate that population of interest into only kinesiology majors at Cal State Long Beach. Okay, so the population is how you, the researcher, define the population, but you have to think about when you are creating generalizable results, which we'll touch on in the next PowerPoint. When you're making generalizable results, your population should be able to be like repeated in the entire world. So while those might be more specific examples to Cal State Long Beach, they could be generalizable to other college programs. Okay, so maybe the population is more of kinesiology students or collegiate kinesiology students or that type of thing. So populations are kind of the larger group of people, and then the statistics that we run on populations are called parameters, which we will hardly ever use that term in this class, but think population parameter, both start with a P, so parameters are the calculations or statistical measurements that we can perform on populations. Not necessarily something we do in this class. What we primarily work with in kinesiology are samples. Okay, this is very, very rare you'd ever be able to collect an entire population, so usually the method of choice is to take a subset of that population, and we call that a sample. So a sample represents a portion or a fraction of a population. They still share at least one common characteristic, and when we collect a sample, we typically assume that the people we have are representative of that population. And then the mathematical calculations we run on that sample are statistics. So that's why statistics is called statistics, because we're often working off of samples. Okay, so parameter, population, statistic, sample. When we collect samples, it's really important that the recruitment is random. Okay, so this would mean every person within the population has an equal chance of being selected. So if we were doing kinesiology majors at Cal State Long Beach, or just collegiate kinesiology members or kinesiology majors using a convenient sample from Cal State Long Beach, we could then sample people from the kin department by putting up flyers in the hallway. We could have the department office send out kind of a mass email to all undergraduate students to see who might be interested in a study, right? But the point being is that within our given kin major population, everybody has an equal chance of being selected. Okay. All formulas and calculations that we use to make inferences about populations are going to be based on the fact that the sample is randomly selected, and random sampling ends up giving us actually a specific shape of a distribution that we'll cover in Module 3. So that component is really important. Random sampling will always be an assumption that we have for any type of statistical test we run in this class. The other reason why we do random sampling is it eliminates bias in recruitment. So if I wanted specifically active people versus sedentary individuals, and I have friends who I know go to the gym like 5 days out of the week or do really heavy lifting, if I went up to those people and said, you get to be in the study and you get to be in the study, that's introducing bias into my sample, because maybe I want to look at the effects of a weightlifting program on hypertrophy or something of the sort, right? If I already know those people are working out X number of days out of the week, I have now introduced bias into the results that I could potentially get from the study. So random sampling kind of prevents or limits the amount of bias that can be introduced into the sample. When we look at how a sample is measured, typically, well, at least for this class, most of the statistical tests we run will have independent variables that are categorical in nature, which we'll touch on when we get to the types of data. But when we have all of the same subjects undergoing all of the same manipulations, so let's say we have individuals we've collected and we want to do a weight training program on them. And we've collected sedentary individuals, so that's our sample. We take a baseline measurement of those individuals for, let's say, how many pounds they can squat. Okay. So baseline would be kind of like one manipulation, or kind of the condition without the training program. And then the second condition would be like post-training program. And then we take the same measurement on how many pounds they can squat. Right? So in that case, we've used the same sample and we've measured them more than one time for two different categories or two different conditions that we then want to compare together. So whenever we have the same sample with a repeated measure, we call it a within subject sample, or when we refer to different types of independent variable conditions, we could also refer to it as a within subject factor. So these are often called repeated measures or paired samples. We won't really get into the nitty-gritty of this until we start talking about t-tests, which is in Module 6, and then we really use it in Modules 7 through 9. But repeated measures using the same sample of subjects, they undergo all of the manipulated conditions. if we're using different people, okay, so I have my little male and female emojis, right? Let's say maybe we want to look at gender differences. So we collect a sample of females, a sample of males. They all share some common characteristic. We have a measurement of interest that we want. We take that measurement on the males. We take that measurement on the females. Okay, 2 different samples have been used. And then we want to compare those 2 samples together. So when we've got that, right, independent samples, we call that a between subject sample, or if we're talking about the type of independent variable that we've used, we could also refer to it as a between subject factor. Okay, so in this case, different subgroups of a collected sample undergo different manipulated conditions. Okay, or there's a characteristic that separates those individuals from each other. So we could also do something of the sort like active versus sedentary. We could look at different diet programs, right? If we gave one sample a keto diet, one sample a paleo diet, and one sample, like their control group, they just eat normal macro amounts, maybe. Okay, those would be all examples of between subject samples or between subject factors. Our next video is going to go over the types of measurement. So go ahead and end this video, and I'll see you in the next one.